Okay, today we're going to go over 4.2 and 4.3, linear equations and applications. This is kind of a long video, but hang in there. These are the objectives of what you'll be able to do when you have learned this material. So let's get started. So first, let's look at the difference between simplifying versus solving. When we are told to simplify, what is it going to look like? When we're told to solve, what is it going to look like? The first thing you should notice is there's no equal sign over here. When there is no equal sign, you cannot solve it. This will be your answer. When you have an equal sign, you have to solve it. This is what your answer will look like. It's important to note that when you're simplifying, you are left with an algebraic expression. When you're solving, we get a numerical answer. We get a number. So that's the first thing to pay attention to, is whether a question is asking for you to simplify or to solve, or if there's an equal sign versus no equal sign. Okay, so let's do some examples of solving equations. We're going to start out easier and head to more complicated. So we have 2x plus 3 equals 17. First thing we want to do is get rid of whatever's farthest away. Now we're left with 2x equals 14. Remember, we do the opposite operation. So if this is adding, we want to subtract. Now we're left with just the 2 times the x. So we're multiplying. We need to divide. And we're left with x equals 7. Kind of like the reverse order of operations. Now that we've got an answer, let's check. We put the 7 in for x and see if it comes up to our answer. Does 14 plus 3 equal 17? Yes. Yes, it does. That's called solving an equation. Moving on, now we have parentheses involved. We need to get that x, so we're going to distribute. We're going to multiply the 2 times the x and the 2 times the negative 4. Then we have some like terms we can take care of. Because they are on the same side of the equal sign, we can combine the 2x and the negative 5x. And now we're left with something that looks very similar to this. We go farthest away from the x, and we do the opposite operation. So minus 8 plus 8. And that leaves us with negative 3 times x. We want to undo the multiplication, so we divide. So because we're looking at this one, that's why it's negative 3. We end up with x equals negative 1. We're going to plug that negative 1 back in for x in the original equation and follow the order of operations. So we do our distributing, or not our distributing, we do our parentheses, then we multiply and divide, then we add and subtract, and we're left with the correct answer. Okay, what if we get x on both sides of the equation? Not a problem. We just have to move the x over to the other side. So you take the opposite sign, you say 5x. So we want a minus 5x because that's positive. And that'll get the x off this side of the equation. So now that we have the x on one side, we need the numbers on the other side. So we're going to get rid of this plus 24. The opposite of addition is subtraction. Then we have negative 36 equals 3x. We have a 3 multiplied with our x. So we're going to divide that 3. We get negative 12 equals x. Plug that negative 12 back into both x's. And we're just going to follow the order of operations. we get negative 72 equals negative 72. That's correct. Wonderful. Oh my golly, this looks like a mess. Let's take it one step at a time. The first thing we're going to do is distribute. So we got a number touching a parenthesis. We got to do that if we can't do the inside of the parenthesis and there's no exponents. So we multiply everything out. And then our next step is to look for any like terms on the same side of the equal sign. So there's the equals. These two are on the same side, so we combine them. And these two are on the same side, so we combine them. Now, this looks a lot like this problem. We've done this problem, so I know we can do this problem. Let's get all our x's on one side and our numbers on the other. Looks like we're doing our numbers first. Okay, then let's get our x's on the other side. And remember, whatever you do to one side, you have to do to the other. Okay, now we're left with 5x equals 30. So 5 is multiplying times x, so we want to divide it. We get x equals 6. Plug that 6 in for both the x's, then do what's in the parentheses first, and then multiply. And then we just add and subtract. We're left with negative 11 equals negative 11. Yay! Ugh. This is our most complicated problem. But don't worry, it's not that bad. What do we do? How are we going to deal with, we have a 2 as a denominator, a 5 as a denominator, and no denominator. Okay, here's how you do it. You're going to look at these two numbers and look for the lowest common multiple of the denominators. And you're going to multiply everything on each side of the equation by that number. So you look at the 2 and you look at the 5, and this would be 1. And you say, what is the lowest common multiple? That's the lowest number that we can multiply and have multiply something by 2, multiply something by 5, multiply something by 1, and have them all go into this number. In this case, it's just 2 times 5, which is 10. So we're going to multiply both sides of the equation. So this side gets multiplied by 10, that side gets multiplied by 10. Then we end up with 30x over 2 equals 80x over 5 minus 40. Now let's simplify. 30 divided by 2 is 15. 80 divided by 5 is 16. And that 40 is just hanging out. Now, this looks like something we have done before. We have our numbers all on one side. We need our x's to be on the other side. So let's get rid of this 16x by subtracting it on both sides. We get negative x equals negative 40. At this point, you either times both sides by the negative 1 or you divide, but x equals 40. Let's check this out. Plug that 40 back into both the original x's. We're going to do the top of the fraction first, then divide, and then subtract. And we have the right answer. Terrific. That one's a little tricky, and if you need to rewind to rewatch it and figure it out, go right ahead. Okay. Infinitely many solutions and no solutions. How do we know? Well, we go through our steps to solve the problem, and we end up with 6 equals 6. The variables have dropped out, and all we're left with is numbers. So you can't solve and say x equals something when we don't have an x. Then you have to ask yourself, does 6 equal 6? Yes, 6 equals 6. If that is a true statement, we have infinitely many solutions. Okay, so let's try no solutions. So we're going to do the same process where we multiply it all out and we end up with no variables again. Does 6 equal 8? No, 6 does not equal 8. So, when we're yelling no, this is not a true statement. We have no solutions. Okay? So, if your variables go away, you will have one of the two. So, here's a question for you. Evaluate x squared minus x for the value of x satisfying this big equation here. First, we're going to solve this equation here to find out what x is. So, how are we going to do that? Well, we're going to distribute. We got some numbers touching parentheses. You're going to want to remember that this is a negative 2 times the 2 minus x. Now we've got some like terms on either side of the equation, so let's clean that up. Okay, now we just need to get our x's on one side and then get our numbers on the one side, the other side from the x's. And then we're left with 2x equals negative 2. So we're going to divide out that 2. And we're left with x equals negative 1. We have more to do. Well, yes, because we just solved this for x. Now we have to take this x equals negative 1 and plug it into this equation to figure out what the answer is. So we plug that in and we solve and we get 2. The answer is 2. That's our answer to the problem. So first you solve the big equation to find out what x is, and then you plug x in to find the answer. So it's a little bit tricky. All right, some algebraic expressions. We have the sum of a number and 7. How about 5 more than a number? A number plus 8. A number increased by 9. 4 added to a number. A number minus 4. With the minuses and the subtraction, you have to be very careful. Some of these are tricky. A number decreased by 5. A number subtracted from 8. Because now we're subtracting the number from 8. The difference between a number and 6. 7 less than a number and 9 fewer than a number. Let's try some multiplication ones. 5 times a number. The product of 3 and a number. Half of a number. Well, that's wrong. It's a half. That should be a 2. 75% of a number. 13 multiplied by a number. Twice a number. A number divided by 3. The quotient of 7 and a number. The quotient of a number and 7. The reciprocal of a number. Now let's do some that have more than one operation. The sum of twice a number and 7. twice the sum of a number and 7, 3 times the sum of 1 and twice a number, 9 subtracted from 8 times a number, 25% of the sum of 3 times a number and 14. There you go. Okay, how about some strategies for solving word problems? Step 1. Read the problem carefully several times until you can state it in your own words what is given and what the problem is looking for. Let x, or any variable, represent one of the unknown quantities of the problem. Step 2. If necessary, write an expression for any other unknown quantities in the problem in terms of x. Step 3. Write an equation in x that models the verbal conditions of the problem. Step 4. Solve the equation and answer the problem's questions. Check the solution in the original wording of the problem, not in the equation obtained from the words. Okay, let's do one. Acme Car Rental Agency charges $4 a day plus 15 cents per mile, whereas Interstate Rental Agency charges $20 a day and 5 cents per mile. For how many miles of driving in a day will the cost of the two rentals be the same? Well, let's look at this. Acme Car Rental Agency charges $4 a day, so we're going to write down a 4, plus 15 cents per mile. So plus 15 cents, or $0.15. Whereas Interstate Rental Agency charges $20 a day. Oh, right. We want them to be the same, so that's going to be an equal. Interstate Rental Agency charges $20 a day. And 5 cents per mile. So we want these to be the same, but we don't know where the variable goes. Ah, yes we do. We're looking for miles. So miles are attached to the 15 cents and the 5 cents. And now we just solve this like any other equation. We get our numbers on one side, our variables on the other. I used m for miles. Then we're left with 0.10 m equals 16. We divide on both sides, and we end up with m equals 160. Then we have to phrase it, see if it makes sense. At 160 miles, the cost for the two rentals will be the same. Okay, your local computer store is having a terrific sale on digital cameras. After a 40% price reduction, you purchase a digital camera for $276. What was the camera's price before the reduction? This is kind of a two-step problem because we're looking at a 40% price reduction. So how much are we going to be paying? You pay 60% of the cost of the camera. So 60% of the cost of the camera is $276. We're looking for the price before reduction. So 276 equals 0.60C. We divide, and we get $460 is the cost of the camera before the reduction. All right, solving formula for one of its variables. The first thing you want to do is look for what variable we're solving for. We're solving for L. So we're going to pretend Like everything else is numbers. So what would we do if this were the only variable in there? Well, we would get rid of this bit over here. This is adding, so we'll subtract. We're left with P minus 2W equals 2L. That again is what we're looking for. So now we have to get rid of the 2. That's 2 times L. So we divide. Then we have P minus 2W divided by 2 equals L. That's your answer. You just treat them as if they were numbers, but then over here we can't combine them. Let's do this one. T equals D plus PM, and we're solving for P. Put a little arrow on P because that's what we're solving for. So we want to get rid of the D first because it's furthest away. We can't combine T and D, so we just leave them there. Now we're still looking to get rid of P. So this is P times N. Let's divide the M. We get T minus D over M equals P. Great! That's our answer. Wonderful. So now you have our notes for today. Don't forget to like and subscribe. Ring the bell if you want to be notified every time a new video comes out. And have a great rest of the day.